So we talked about catalysts and enzymes and how they've worked and everything. Now, the last thing we're going to talk about is exothermic and endothermic reactions. And what does that have to mean? Basically, anytime we take atoms that were joined together and we break those bonds and recombine them, okay, there's going to be a change in the amount of energy, because some chemicals involve more energy to hold them together. All right. So for example, if you have two oxygens joined to a carbon, that's probably going to take more energy than for two oxygens to hold on to each other and the carbon to come off by itself, like it would over here. Okay, that's a decrease in the amount of energy, and that energy has to go somewhere. It can't just disappear. Conservation of energy says that energy cannot be created or destroyed, so it has to be given off. Okay, and so if the resulting bond requires less energy, then there's going to be extra energy that's given off. If the resulting bond takes more energy to hold it together, then there's going to be a less energy in the atmosphere around it. The energy that it takes to hold the chemical together is called the bond energy. Okay, how much energy does it required to hold these bonds or atoms together with these bonds? Okay, and so we can say that it's the energy that's required to pull two atoms apart okay, or we can express it as saying that it can be the amount of energy released when two atoms or chemicals are brought together. All right. Ran out of space there, but okay. So basically, this bond energy is either if you have two atoms that are together, it's like, well, how much does it take to tear them apart? Or it can be the amount of energy that when you bring two atoms together, how much energy do they release? Okay. So at any rate, bond energy is just how much energy is used to make certain bonds, and some bonds require more energy than others, and that's just kind of the way that works. Okay. And so when we want to know if something's exothermic or endothermic reaction, a lot of times we say exothermic reactions, that are reactions that give off energy or release energy. All right, give off or release energy, and endo, meaning inside, bringing in, are reactions that take in energy. Okay, endo meaning bring in, thermal means heat or energy, so take in energy. All right, and that's a pretty good definition, but we need to kind of explain exactly what we mean by that. Okay, for example, if I burn a piece of paper, is that exo or endothermic? Okay, and in order to make it happen, if I just have a piece of paper in my hand, is it going to spontaneously burst into flames? No, it must take in energy. Okay, and so some people say, well, that makes it endothermic. You have to light a match and apply energy to make it happen. So in that sense, someone says, well, it's endothermic. Now, once it starts burning, it gives off and releases lots of energy. So someone would say it's exothermic because of that. Okay, it both has to take in energy and it has to give off energy. Okay, the key has to do with the net energy. All right, of the reaction. If you talk about the net energy, it's how much did it take in compared to how much did it give off. The formula then for the net energy is equal to the energy absorbed by the chemicals, and that's considered a positive, plus the energy released. Okay, and so that's going to be a negative, because as far as that chemical is, it's losing that energy, it's giving it off, so it's considered a negative. Okay, and that's the energy released. Okay, now if you think about in terms of the piece of paper, it absorbs a relatively small amount of energy. Okay, let's just say 30 joules, just to give it a number. Okay, and it releases many more times that. Let's just say 120, just to make it a nice even number. Okay, it loses that. So overall, we would say that it releases or gives off or loses 90 joules of energy into the air. Okay, therefore, we would say that this reaction is exothermic because it gives off more energy than it takes in. Okay, and so that's the deal. If a chemical does not require any energy to happen, it's just going to happen automatically without any kind of input of energy or whatever. They would be spontaneous, just poof, boof. Just like there are certain chemicals you mix together and poof, they just automatically react because they don't require any input of energy to happen. But most reactions aren't like that. They require some input of energy to happen, and so they only happen when they get that little input, even though they may give off, in this case, a lot more energy than what they brought in, and therefore they're exothermic. Okay, endothermic, on the other hand, would be one that takes in a whole lot more energy than it gives off, and therefore we say it takes in energy. It's a net take-in of energy. If we look at these two examples, in this one we have hydrogen and oxygen. Hydrogen and oxygen, once again, are gases. If you just mix them together, they're not just going to spontaneously react. They have to have an input of a certain amount of energy. But once they react, it takes less energy to hold hydrogen and oxygen together in water than it does to hold hydrogen and oxygen equal. So you have to put in energy, but then they would give off or lose and give off a lot more energy, and therefore by the time we would consider that an exothermic reaction because it's going to give off more energy than it takes to make it get started. The nitrogen and oxygen, also two gases in the atmosphere though, these are the ones that take a lot of energy to put them together, and once they get put together they may give off a little bit of energy, okay, but nitrogen monoxide would have this much more energy in its molecules. It takes that much more to hold it together. So it has absorbed this much energy from the environment, and that's why it takes something like lightning or something to have this big input of energy. Even though once you put it together it gives off a little energy, it takes a lot of energy to get it together, and you have to put more into it than you get out of it. So that would be an example of an endothermic reaction. All right. Now, in general, we say that energy wants to disperse and spread out. Okay, it wants to go from an area where it takes more energy to hold them together to energies where it takes less to hold it together. And so energy wants to disperse or spread out, and that characteristic is called entropy. All right, entropy is where energy wants to disperse or spread out. And this is kind of the natural way that reactions want to do. These tend to occur more naturally. When they spread out their energy and release and give off energy, those are more likely to occur. Reactions like this that require a lot of input energy and they take more energy to hold them together than they did for the way they are, that doesn't tend to happen very rarely, except for like lightning strikes in your human body. Our bodies, we think of entropy as decaying and breaking down and spreading out the energy. We want to concentrate and build chemicals, make chemicals that are more complicated to hold together. That's what our bodies do. And so we are constantly using energy to build chemicals. That's why we have to continue to eat food. And then we eat food, we have to get plants or animals to eat, and they have to constantly receive energy from the sun. If the sun quit putting energy into the system, the whole thing would start breaking down, and we would not have enough energy to build all the chemicals, because we're basically going against the grade. Instead of letting energy spread out, we're trying to concentrate energy in all the different compounds in our body, and so we're kind of going against the flow there. So these endothermic reactions, you have to constantly have energy to keep going that, because you're concentrating energy in these new structures that you're building, like in your body. So endothermic is, we say it decreases entropy, which is going against the natural grain, if you will, and so that's very difficult to do. Exothermic reactions that release energy and let it spread out to other places, that's just kind of the natural way that most things want to do and occur on their own, and so entropy is increasing in that case, and that's just the natural flow of things. But we can, as long as we have input of energy from the sun, we can go against that and build and complicate more structures in our body. All right, hopefully that's as clear as mud, and there we go. All right, and that finishes our notes so for chapter 20, and that's a good thing. Have a good day.